Hi students, I am Anilkumar, working as a science teacher in Sri Guru Padeshwara English Medium High School, Sanehalli. Students, in today's class we are going to learn the chapter motion, the 9th standard chapter, that is motion. Okay, students, you are looking in the figure. Birds are flying, the cars are moving, and the atom is inside the atom. There are electrons revolving around the nucleus, and the atom is also in continuous state of vibration. Here the birds are flying from one place to another place for their food or for their water. Okay, they have to seasonally they migrate. That is what we call it as motion. And whatever the electrons revolving around the nucleus, that is also called it as motion. And the car moving from one place to another place, these are the bunch of cars are moving, they are moving one place to another place, this is called it as motion. Okay students, here look here, in our solar system, the sun is at the center. The sun is at the center, and around the sun the 8 planets are revolving. The 8 planets are revolving around the sun. Okay, this is also a motion. Sun is at the center, and our solar system, what is that? Solar system, that is we have the 8 planets. Those 8 planets are revolving around the sun. This is also motion. They are revolving elliptically. That is elliptical motion we call it as. Okay, then next students, here you are looking, that is what? A tree, that is coconut tree, is bending. The coconut tree is bending. Why that coconut tree is bending? Because of the wind force. Then what it refers, what it infers, what it shows to us? This shows us, what it shows, that is wind is moving from one place to another place. We cannot see the wind, but that bending of coconut trees infer us. What did they infer? The coconut tree is bending. That means wind is moving from one place to another place. And you are looking the sun. It is sun rising and sun setting. Sun rises in the morning and comes in the afternoon in our overhead, and in the evening what happens? He sets. Is that sun is moving then? No. Yes, sun is not moving. Then who is moving? The moving is our earth. Our earth rotates and revolves around the sun. Therefore, the motion of the sun infers that our earth is moving. Our earth is in motion. Okay students, then what is motion? If any object that changes its position with time, then it is called it as motion. Okay students, in this chapter what we are going to learn? In this class what we are going to learn, that we will see one by one. Okay, in this chapter we are going to learn, that is first one is describing motion along a straight line, uniform and non-uniform motion, the measuring the rate of motion. In this again we will discuss speed, velocity and acceleration. The measuring the rate of motion will discuss speed, velocity and acceleration. Next is graphical representation of the motion. In the graphical representation we will discuss distance time graph and velocity time graph. Next we will discussion about the equation of motion. 3 equations we will discuss. What are those? We will see later. 3 equations of motion, and we will discuss about uniform circular motion. Uniform circular motion. Okay. First we will go to the first concept, that is describing motion. Here students, you are looking a home and a school. You are moving from home to school. You are moving from home to school. Home to school we measure some distance. ಡಿಸ್ಟೆನ್ಸ್ ಅಂದರೆ ಕನ್ನಡದಲ್ಲಿ ದೂರ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ದೂರವನ್ನು ಅಳಿತೇವೆ ನಾವು. ಓಕೆ, ದಟ್ ಈಸ್ ವಿ ಆರ್ ಮೆಸರಿಂಗ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಹೋಮ್ ಟು ದ ಸ್ಕೂಲ್. ವಿ ಆರ್ ಮೆಸರಿಂಗ್ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ಹೋಮ್ ಟು ದ ಸ್ಕೂಲ್. ವಿ ಆರ್ reference point. What is the reference point for us? Home is the reference point. We take what? We take, that is home is the reference point. We take home is the reference point. We take this, home is our reference point. We take home is our reference point. To measure the distance of school from the home, we took home is the reference point. Okay students, from home to school, say 5 kilometer distance. We referred home as a reference point. Whatever the reference point we taken, that reference point is called it as origin. Is called it as origin. That is, the reference point is called as origin. That is, the reference point is called it as origin. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಏನು ನಾವು ರೆಫರೆನ್ಸ್ ಪಾಯಿಂಟನ್ನು ಏನು ತೊಗೊಳ್ತೀವಲ್ಲ, ಡಿಸ್ಟೆನ್ಸನ್ನು ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ ಆ ರೆಫರೆನ್ಸ್ ಪಾಯಿಂಟಿಗೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ? ಆರಿಜಿನ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಕನ್ನಡದಲ್ಲಿ ಮೂಲ ಬಿಂದು ಅಂತೇಳಿ ಕರಿತೀವಿ, ಆರಿಜಿನ್. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಹಿಯರ್ ವಿ ಆರ್ ಟೇಕನ್ a straight line in kilometer line. On that we are taking the points A, B, C and O. We are taking the points A, B, C and O. Here O is the origin. O is the origin. O is the origin. We start an activity. O is the origin. O is the origin. We are moved from O to C. You are moving to O to C. You are moving O to C. You covered a distance of 25 kilometer. You covered a distance of 25 kilometer. Then you move C to B. You move C to B. C to B, what is the distance there? C to B, 25 to 35. What is the distance 25 to 35? That is 10 kilometer. You moved a distance of 10 kilometer. Then you moved O to A. You moved O to A. You moved O to A. What is the distance of O to A? 0 to 60. That is 60 kilometers. You moved a distance of 60 kilometers. Then from A to again you come back to C. From A to again you come back to C. You go O to A and A to C. You come back. What is the total distance then? What is the total distance then? That is OA plus AC. You moved O to A and A to C. That is O to A is 60 kilometer and A to C is 35 kilometer. Total 60 plus 35 total is 95 kilometer. You moved 95 kilometer. Then again you moved O to A and A to O. You moved O to A to O. What is the total distance? O to A to O. O to A is 60 kilometer, A to O is 60 kilometer. 60 plus 60 total is 120 kilometer. You moved 120 kilometer. Okay students, then what is this distance meaning? That we will see. What is the meaning of distance then? Look at here, distance, the actual path covered by an object is called distance. The actual path covered by the object is called as distance. ಯಾವ ಒಂದು ಆಬ್ಜೆಕ್ಟು ತನ್ನ ದಾರಿಯನ್ನು ಕ್ರಮಿಸ್ತಾ ಹೋಗ್ತದೋ ಆ ದಾರಿಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ಡಿಸ್ಟನ್ಸ್, ದೂರ. ಕನ್ನಡದಲ್ಲಿ ಹೇಳೋದಾದರೆ ದೂರ ಅಂತೇಳಿ ಕರಿತೇವೆ. ಓಕೆ, ದಟ್ ಈಸ್ ಆ್ಯಕ್ಚುವಲ್ ಪಾತ್ ಕವರ್ಡ್ ಬೈ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಕಾಲ್ಡ್ distance. Then another concept comes, that is displacement. Displacement is the shortest distance between final position and initial position of the object. That is the shortest distance between the initial position and final position of the object is called displacement. The shortest distance between initial position and the final position of the object is called it as displacement. Okay students, here we will discuss in this figure we will discuss what is the difference between distance and displacement. What is the difference between distance and displacement? Looking here, a boy is riding a cycle. He rides from point A to point B, then point B to point C. He riding a bicycle from point A to from point B to point C. He is riding. Okay, look here the figure, students. Look at the figure. Okay, he is moving from A to B. First he moved from A to B, then in the home he drinks some water, then he moved from B to C. He moved from A to B and B to C. Then what is the total distance he covered? What is the total distance he covered? What is the total distance? That is A to B is 4 meter and B to C is 3 meter. 4 plus 3 how much? 7 meter. 4 plus 3 is 7 meter. He covered a distance of 7 meter. But looking here, from point C to point A, from point C to from point A, what is the shortest distance? That is shortest distance is 5 meter. That is the shortest distance is 5 meter. This shortest distance, what we call it as displacement, and that is whatever he actual path covered. That actual path is called it as distance, and the C to A we have a shortest distance. That distance is called it as displacement. Students, ಡಿಸ್ಟೆನ್ಸಿಗೆ ನಾವು ಕನ್ನಡದಲ್ಲಿ ದೂರ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ಗೆ ನಾವು ಕನ್ನಡದಲ್ಲಿ ಸ್ಥಾನಪಲ್ಲಟ ಅಂತೇಳಿ ಕರಿತೇವೆ. ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಈಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಝೀರೋ ಆರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಝೀರೋ? ದಟ್ ವಿಲ್ distance should not equal to 0. Distance should not equal to 0. That means distance never becomes 0. Is displacement become 0? Yes, it may become 0. It may become 0. Displacement may become 0. Then what is the condition that displacement is 0? That we will see. Displacement is equal to final position minus initial position. Displacement is equal to final position minus initial position. That is, we are taking one figure here. That is, a boy is walking on a rectangular track. Here students, he walks A to B, B to C, C to D and D to A. A boy walks A to B, B to C, C to D, D to A. You are looking here, boy starts walking from A, point A, then he moved to point B, then point C, then point D and then point A. Again he come to point A. He starts walking from A, B, C, D and again A. He come back to A. its initial position is A, that is starting point, and final position, that is ending point, is also A. There, that is distance is equal to final position minus initial position, that is A minus A. We get what? 0. We get what? 0. That means when the initial position of the object is equal to the final position of the object, then the displacement is 0. Then the displacement is 0. This distance should not be equal to 0, but displacement may equal to 0. Then what is the condition that displacement equal to 0? That is displacement is equal to 0 when initial position of the object is equal to the final position of the object. Okay students, we will move to the next concept, that is uniform and non-uniform motion. Uniform and non-uniform motion. Then what is uniform motion? If an object covers equal distance in equal interval of time, if the object covers equal distance in equal interval of time, then it is called it as uniform motion. Let's see the figure. Whatever, a car is moving on a road. The car is moving on a road. Here, looking here, okay, car is moving. It is moving at a 40 kilometer speed. Okay, it is moving at a 40 kilometer speed. It starts at 0 time. That means we are recording the time at the starting. It's start to move. At 60 minutes, it covers a distance of 40 kilometers. Look here, this is the car. Car is moving. At the 60 minute, it covers a distance of 40 kilometer. It covers a distance of 40 kilometers. And secondly, 60 to 120. 60 to 120. That is again in the second hour. It covers a distance of 40 kilometers. It covers a distance of 40 kilometers. That means every hour, that is first hour 40 kilometer, second hour 40 kilometer, third hour 40 kilometer, fourth hour 40 kilometer, fifth hour 40 kilometer. In every hour, it covers the distance of 40 kilometer. This is called uniform motion. The time is equal and the distance whatever it covered, that is also equal. This type of motion is called it as uniform motion. And again, if you consider the motion of the earth, okay, it covers, to rotate around it, it takes 24 hours. Okay, to revolve around the sun, it takes 365 days. This is also one of the uniform motion. Uniform motion means if an object covers equal distance in equal interval of time, then it is called as uniform motion. And non-uniform motion. What is non-uniform motion? Exactly opposite to that of uniform motion. What is non-uniform motion then? If any object that covers unequal distance in unequal interval of time. If any object that covers unequal distance in unequal interval of time, then it is called as non-uniform motion. Any random motion is example for non-uniform motion. That means if any car is moving in a traffic road, when the traffic is very less, the car moves faster. When the traffic is very high, the car moves slower. It should not cover the equal distance in equal time. Therefore, these type of motions are called as non-uniform motion. Okay students, further concepts we will continue in the next class. Okay, before that you go through these home assignments. First one, define distance and displacement. You have to write the definition for distance and displacement. What is motion? Give example. What is motion? Give example. Okay, you have to write the definition for motion and give example. Okay, here one figure is given. From the figure, you have to find the distance and displacement in both the cases. Okay, in this figure, boy walks from A to C. And second one is A to D. He walks A to C and he walks A to D. A to C, what is the distance and displacement? A to D, what is the distance and displacement? You have to find that. Then what is uniform motion? Give example. What is uniform motion? Give example. Dear students, here you have to write the SI unit of distance and SI unit of displacement. I am not explaining that. You have to, already you know the SI unit in 8th standard. Okay, you have to write SI unit of distance and SI unit of displacement. Okay students, we will continue in the next class.